What's up chat? If you're new here, my name is Eidos and I'm solo developing a 3D platformer RPG with a heavy emphasis on flexible acrobatic movement and complex non-linear quests. This is the first of several videos that I'll be doing during the summer that are about various features that are a bit more technical than what I've covered so far, and the work that I'll be doing during these weeks will all be in pursuit of getting a demo ready, which I'll release on Steam, although the exact release date for that is still uncertain. Anyway, last weekend I was planning to make a video about modeling architecture in which I would demonstrate the process and explain the approach to making buildings, as well as to explain the general mindset that I go with when tackling projects that sit right at the edge of what I'm capable of. But instead, I found myself doing a bunch of bug fixes, doing a bunch of refactors, and solving long-standing problems by coming up with and implementing new features, the most important of which I came up with at 2 AM in the morning. None of those things were planned, but I'm glad I did them. But then on Sunday, when I really wanted to get the building video done, I took a screenshot of my game and I was reminded that while the game often looks great when it is running, screenshots tend to look pretty bad. So instead of making the building video, I decided to instead work on making screenshots not look terrible. This is an issue all developers face because the problem is fundamental. We take a medium where everything is designed around being dynamic, where moving elements are used to create the illusion of depth in a 2D image, and we discard all of those dynamic elements when we compress it down into a still frame. To illustrate this, think about some of your favorite games and think about how good they look, and then look at the screenshots on the Steam page. You'll probably find that the game you like so much looks pretty awful, even though the people who took those screenshots are literally paid to make their game look good on the storefront. I have a script that uses FFmpeg to easily trim video files so I can quickly make and post short clips, kind of as a replacement for screenshots, but the reality is that screenshots are important and I really should focus on getting those to look good. So the objective is to create a photo mode that has all the features built in to make the game look really good in screenshots, and it's actually a really good opportunity to go over the workflow and the mindset that I have when it comes to implementing any new feature. So the most important thing to acknowledge with anything you haven't done before is that you cannot predict how things are going to develop. You don't really know what's a good idea, you don't really know what's bad, because you just don't have the experience yet. Naturally, this means you should keep things simple at the start, because the likelihood that you're gonna have to redo all of the work later is high. With this in mind, let's think about what a photo mode is and how it should be approached while keeping things as simple as possible. Well, a photo mode is basically a glorified screenshot tool, so the first step, while keeping things as simple as possible, is just to get the game to take a screenshot. But actually there is another step that comes before this. Games are very large and very complicated state machines, and it takes some work to even get the game into the state of screenshot taking without collapsing. Thankfully, I already had a system and a workflow in place for managing state transitions in my game, so it didn't take long to get to the point where the world would freeze and control was granted over to the screenshot system. When the state management was in place, it was time for the difficult part, taking the screenshot. Except actually it's literally just one line of code. Unity gives you a function that you can just call and it does what you want. But with this figured out, we're back to the original problem, the reason why we're even doing any of this, which is that screenshots looked bad before. Part of the reason for this is that the game has LODs, which are low level of detail versions of objects that are displayed when these objects are far away. This is fine when the game is running because you tend to be focused on things that are up close, and even if you do stare at a distant object, the screen is probably moving and the imperfections are harder to notice. But when we freeze the world, none of these things help, and low level of detail objects are fully exposed when they really don't have to be. So I went ahead and wrote some code to temporarily disable LODs across the entire level when taking a screenshot. However, there is another thing that has LODs implemented but in a different way, and this is of course the foliage. The foliage is by far the most expensive effect in the game because we're talking about literally millions of 3D objects that need to be rendered. Limiting the draw distance for foliage is necessary if you want the game to run beyond 20 FPS, but in a screenshot we're running at 1 FPS anyway, so we can just disable that. So now we've got a screenshot button, and when pressing it we take a very high resolution screenshot of the game with the draw distances set to infinity. And screenshots do already look a lot nicer, but we're not just making a screenshotting tool, but rather a full-fledged premium AAA luxury photo mode. So then we have to ask, what is the next step in making this premium photo mode? And my thought was the camera. Photo modes need to allow you to move the camera wherever you want, so I went ahead and implemented this. As I said in the beginning of this video, I had been doing some work on various systems, and one of these systems was the camera system. I took what was previously a monolithic blob of complicated code and turned it into a modular system. And with this system I can slot in a new camera mode pretty easily, isolate it from the complexity of the other camera modes and just implement its specific functionality. And this is where another important question is raised. When implementing something, how much time and energy are you willing to allocate to doing background research before getting to work? When I was implementing player movement and the corresponding camera, I was forced to become very familiar with vector math, and I had to learn all the unintuitive pitfalls you fall into when actually putting it into practice, and I had to spend weeks refining and rewriting and refining all the architecture to get to the stage where the game is currently at. But this time I really don't want to have to do any of that, and I just want to have a photo mode where I can move the camera around, and it really doesn't have to be anywhere near as complicated as what I had done before. So I decided that my time allocation for relearning how cameras are made would be approximately 0 minutes and 0 seconds. Basically, I just wanted to get this thing done fast, and I just got to work. I initially tried to create a velocity and friction based system where the camera would be smooth but responsive, but it didn't take long to be reminded of just how many problems you're gonna have to solve when doing this. If you have friction, do you apply it always, or do you apply it only when you release the control stick? And what if you stand still and you try to move, but then the friction destroys the velocity and you just stand still again? Well, I have the solutions to all of these questions in my existing code, but I really didn't want to have to do research all over again. So instead, after about an hour, I decided to redo the implementation from scratch and basically just directly map the controller inputs to camera movement. It turns out that this is actually by far the best way to handle this, because you get very accurate control, and because the code is so simple, it's easy to add other features like movement boosting on top of it. There are a few more things that I had to work on, like camera collision and all the state management stuff, as well as a few bug fixes here and there. Also bugs that were already a thing before, but which the photo mode finally highlighted. But none of that is too important. The photo mode camera was done, and I could move on to asking what the next step in developing the photo mode would be. So, photo modes in modern games tend to give you control over things such as character poses and post-processing filters. Of course, that means that my game needs to have all of these things as well. I started by providing an option for FOV, except I couldn't yet provide an option because I didn't have a menu. I did have a large chunk of custom UI code that I use as the base for all my menus, but none of these menus had the features necessary to implement what I wanted to do for the photo mode menu. Specifically, I wanted to have buttons that you can cycle through horizontally. Thankfully, despite the UI being an object-oriented behemoth that would probably convince Jonathan Blow that computers should never have been invented, it was actually very easy to extend and expand. The result? A simple UI that just allows you to change settings. So I implemented FOV, and there's nothing I can really say about this because it was really easy. I then integrated daytime configurations into the menu, and these are basically packages that specify lighting, fog, and post-processing for a specific time of day. And cycling and activating these was pretty easy to implement because I already had all the infrastructure in place to do this. Next was the poses. The Blender file for the main character is kind of broken right now and it's gonna get restructured soon, but I really just didn't want to open it and do any more work in there, so instead I took existing animations and used those as poses. Implementing this feature was very easy because it basically just boiled down to storing some information about poses and then loading them into the animator component when necessary. Next up, I wanted to have an optional mode where the main character is always going to be in focus and everything else is blurred, replicating how focus works on real cameras. This is done via depth of field, which is part of the post-processing stack, and that's a problem. If I let the player modify a post-processing filter that I carefully tuned, then I should guarantee that the user is modifying a copy of the filter and not the original. Again, it wasn't difficult to implement, but only because I had already spent quite some time working on the architecture behind managing post-processing filters and related things a few weeks ago. At this point, precisely 24 hours had passed since I started late in the evening of the previous day. I still had a few bugs in the code, but the core structure, the design, and the implementation of the things that really mattered, that was all done. One day is not a lot in the grand scheme of things, so I was and I still am pretty happy with the progress that I made, despite getting stuck on a few things that I used to know very well but which I had unfortunately kinda forgotten. A key pattern that you've probably picked up on is that a lot of things were easy because I had already done architectural work beforehand. Again, video games are state machines and you can implement it all in a very messy way, but when you implement a new feature, you will feel it. In some of my previous videos I talked about working on various systems that you cannot really see, and hopefully this shows that all that work actually had a purpose. Anyway, at this point I had proven to myself that the photo mode would work, but I still needed a few things, of which the first was to have a prettier UI. At this stage my UIs were very inconsistent, and actually they still are because I haven't yet updated them all, but the problem back then was that I just didn't have a refined workflow for creating new UI elements that were consistent with the style of others. So I spent some time working on the new UI workflow, taking the system I used for generating collectible icons and expanding it to support any image. And on the Blender side I spent several hours working on the workflow for creating metallic frames that most of the UIs would be built of. Unfortunately, this workflow relies on a horrible spaghetti geometry nodes monstrosity that I absolutely hate, but hey, at least it works. Anyway, I eventually got to the point where I could look at a UI, think, I want this text to be enclosed by a metal frame. I would then make the frame and just put it there. It is a very simple and reliable workflow that I'll soon use to rebuild all of the UIs and make them all consistent. So, now the UI was a lot closer to where it had to be, and I decided to add a few more controls to the photo mode. I added support for chromatic aberration, brightness, bloom and saturation, and with each of these I improved the architecture a bit, and by the time that I got to implementing saturation, it only took 5 minutes of work. So that's basically all of the work that I did on this photo mode. The core of photo mode took 1 day, and then I had to go on a UI building side quest, and then I spent an hour or two working on the architecture and the implementation of the remaining controls. But really, photo mode was figured out on the first day when I integrated post-processing with a depth of field option, and everything that came after, that was kind of trivial. It was a very simple project that hopefully illustrates much of what the process is like when I implement a new feature, and hopefully you guys are going to enjoy the photo mode when I finally get the demo done. Thank you all for watching, and stay tuned for the next video, which I'm gonna make either next week or the week after, and it'll be about the implementation of a new system for building and managing expansive non-linear quests. So, see you all next week. Bye bye.